Today we are going to talk regarding another most important part, is a new chapter from our book regarding the image processing, which is about the image segmentation. Today we will cover the theoretical part, more theoretical part from this concept about detection of discontinuous edge detection, which is one of the important job in image. Then we will talk regarding the edge linking and boundary detection, edge linking based on Hough transformation. And in the second lecture of today, we will talk about thresholding, some concept regarding basic global thresholding, optimal global and adaptive thresholding, and local thresholding. These are the concepts that today we will cover. And then 10 minutes of last lecture of today, Roy will talk us about his project. And as we talk and we confirm the date, from this lecture, 10 last minutes of any lecture, this is students' presentation, which we will give them the mark, and it's the portion of your midterm exam that we will consider it as the midterm, some part of midterm exam of this semester for the subject. Okay, if I think everything is okay, let us fast start that Roy can have the proper time for his two-day lecture. And then yes, roughly I have done the attendance, first attendance. Anyway, just I'm waiting for the feedback from Roy. Roy, if everything is okay, I start. Okay, well, image segmentation is the way to substitute the image into its consequence region or object. This is the concept and the work that we are searching to do with the help of image segmentation. Segmentation should stop when the object of interest in an application have been isolated. And the algorithm regarding that generally are based on one or two basic properties of intensity value, discontinuously, and similarity. Then maybe in the initial entering for this concept will become clear for us that in image segmentation, now we are searching for one target or one aim in our image. In the other words, I can tell you that the method which we will use in the image segmentation will help us to focus on some specific part in our image, which will indent or will be finding the object, or maybe in the next block for the work for image processing work for us, will intended for us to detect and some object, some specific aim inside our image. The approach based on discontinuously is to partition an image based on abrupt change in intensity, such as edge in the image, which is one of the most important, we can say, feature in the image, means that edge detecting job. And the approach based on similarity is to partition an image into the region that is similar according to set of predefined criteria. Suppose in the region part, maybe I'm searching for a specific sun in some specific region in my picture. And in the discontinuously, we may be searching for the edge which will be generated by the sun or by a specific object in my image. Let us continue more and go deep for this concept, which I can say even after implementing these algorithms and methods in the MATLAB, then you will have more interest in the DIP lecture. There are three types of gray level discontinuous way. Discontinuous way. Point, line, and edge are the ways that you can have the gray level discontinuous. Edge pixel are pixel at which the intensity of an image function abruptly change, and edge or edge segments are the set of the connected edge pixel. In the edge model, there are three basic edge model that we can set: the step edge, ramp edge, and roof edge, which briefly we can say that the step edge is the transition between two intensity levels occurring identically over the distance of one pixel. Mainly this step image, we can say, suppose if you will see from the gray level value, okay, in an image, when you go to the border, you will see that the border has the darker line from one side, and another side you have more intensity. Then these can be the step edge for us. The ramp edge can be the transition between two intensity levels occurring generally over the distance of several pixels due to the blurring, the slope of the ramp, and hence the width of the edge is directly proportional to the degree of blurring. This blurring also you will see at the corner side of your image. And roof image is the model of line between two regions. The width of the edge is determined by the thickness and sharpness of the line. And what we understand now? We understand that very fast edge detection in the gray level discontinuous method will be specified by the three concepts of step, ramp, as well as roof edge. Let us see them in the figure. In this figure, I show you the model of the gray level profiles from a step as the first one. You see exactly in the first one you have the very broad line 0 and 1 between the gray level and between the dark side and the white side side of our image. It's very sharp. You see 0 and 1 first image here we have. Then in the next one, as a ramp one, you have some value between this 0 and 1. See, something like the ramp. And the next one, you have some roof edge. Why this is roof edge? Because one side is 0, another side is 0. Then you have some peak between them. Then that is why they call it roof edge. Okay. Then this image will help us to understand the type of the edge in our gray level image better. Let us continue more and see. The common approach to run a max approximating either the first order derivative or gradient operator or second order derivative as the Laplacian operator. Then if we want to know from the suppose gray level profile, and if you think as the suppose you have the gray level profile, first derivative and second derivative of the figure that we have will come as the gradient operator, And for the second order, we have the Laplacian operator that can do that. This is something like having the signal view about the image, or just see the image as the one form of signal. Yeah. Because really what we can see from the image, we know image as some matrix value, which then if it's in the matrix value, then you can convert it into the mathematical concept. And from the mathematical point of view to the image, if you want to take the first derivative, it's equal to the gradient operator. And if you want to take the second order one, it's equal to the Laplacian operator. The magnitude of this first order derivative or gradient is used to determine whether the point on the ramp, and the sign of the second order derivative or Laplacian is used to determine whether an edge pixel is either on the dark at the left side or edge on the right side of the edge. Then this figure is very nice because it will show the lots of idea or the core idea about this edge detection in the gray level image. Then if now we want to see this gradient operator or first order derivative equation from mathematical formula, we can see that the gradient of the function of our image f, x, and y can be defined as the vector. You see that here I take the derivative of f, x, and y regarding the x and y, then I can split it and take the derivative 1 from the x, and then they take the derivation from the y. In the other form, I can separate these two sentences as gx and gy as the gradient regarding x and gradient regarding the y. Then the Jx is gradient along the x direction, and Jy is gradient along the y direction. In the other form, the gradient operator based on my image has two vectors, which one is in the x direction and another one is in the y direction. To find the magnitude of this function and the phase which it has, then you can take the root 2 square RT of the Gx and Gy, and theta as the tangent inverse of the Gy regarding Gx. It's exactly the mathematical that we have in the mathematics course. Means that this vector, now if you want to see that what is the magnitude of that and what is the degree or of this vector in the mathematical form, it can be calculated simply based on these two parameters, and see that the gradient is a nonlinear operator. Then the magnitude of gradient is often approximated either using the difference along x and y direction, as we can show it here. Something like this example as I bring. Suppose you have 2 by 2 matrix, which has an element of Z5, Z6, Z8, and Z9. And then the magnitude of these can be, suppose, the subtraction between Z5 and Z8, and in the x direction, and in the suppose y direction, it's about Z5 minus Z6. Then if we calculate this, or using the cross difference along the diagonals, you will see that the magnitude of this delta f, or changing of my function, will become like the formula that I showed here. The magnitude of Z5 minus Z9 plus magnitude Z6 minus Z8, which can be calculated simply in the mathematical form. Then the pair of 2 by 2 mask, that things that we see, that matrix was nothing but our mask. And last lecture about the convolution, we talked regarding this kernel or this matrix which going to sweep all our image to do the convolution on my image side. Okay. Then the pair of these 2 by 2 masks, known as the Robert-Cras gradient operator, which using the Cras difference along the diagonals and can be shown like this. Means that if my this 2 by 2 has the value like this 1, 0, and 0, 1, 0 minus 1, we know it as the Robert Cras, and the gradient operator can be the value of 0, 1, minus 1, and 0, as I shown in the below matrices here. Then using these 2 by 2 mask has the practical difficulty as it does not have the center, and hence masks of size 3 by 3 are often preferred. Why? Because if you remember, we had the concept of neighboring pixels. Then the dimension of 2 by 2, because I cannot find a center for my matrix, it may be difficult to calculate. But if I put it as the 3 by 3, means that I change my dimension by 3 by 3, I can have some element like Z5 as I shown in the matrix here. And then you will see when it will sweep all my image to put the mask on that, like the convolution job, you will see that it can be calculated maybe better. Then simply we can say in the suppose x direction and y direction, what could be the calculation? Suppose z1 plus z2 plus z4 minus z6 minus plus z7 z9, then the value amplitude of that plus amplitude of z2 plus z3 z6, like the vector view to the image. You can calculate the changes or theta delta of f which we have in our image. Then if we have 2 pair of these 3 by 3, we know that the Prewitt or Sobel operation. Okay, what we understand till now, we understand that we have one mask which can be the matrix of suppose 2 by 2. If it will be with the 2 by 2 method, then it will be Robert Cras. Remember this word, Robert Cras. If it will be in the form of 3 by 3, we know it Sobel operator or Prewitt Sobel, that people know it as the Sobel. And using the difference along x and y direction to detect the horizontal and vertical edge, it can be shown here. Prewitt Sobel, it's like the matrix that I show here, and people know this type of edge detection as the Sobel or Prewitt. Okay. In MATLAB also we have the same name and function for this edge detection method. Okay, this 3 by 3 mask, or these 2 pair of 3 by 3 masks known as Prewitt and Sobel, using the difference along the diagonals to detect the diagonal edge as are shown here. Means that think that we have now 2 type of masks, 2 3 by 3 masks, which go and sweep and then detect the diagonal edge of the image. That was from the gradient or the first order one. Then for the second order or the Laplacian operator, for the function image of f, x, and y, we can define it as the square as the root power 2 of changes of my image matrix, image formula fx1, which now you can take this regarding the x and regarding the 1, then you should know that this operator is a linear operator, and the discrete from the Laplacian of f(x) and 1, taking the 4 neighbors into account, and it's obtained by assuming the discrete form of the partial derivatives along x and y direction, as we can shown here. Then now think for the mask or the matrix of 3 by 3 as we shown here. Then the Laplacian or changes of the f can be uh, based on the formula that we shown here. And then here, if we are talking taking all the 8 numbers into the account, it's obtained by summing the discrete form of the partial derivative along x and y direction and along the distance based on this formula. Then if you want to know the all 8 neighbors of one specific pixel, you can use this formula, and the corresponding 3 by 3 mask can be like the form that I shown here. Then the Laplacian is generally not used in the original form for the edge detection for the following reason. First is that the second order derivative is unacceptably sensitive to the noise. Second thing is that the magnitude of the Laplace reduce the double edge. Then remember that the Laplacian had some problem on our edge. With somehow we will avoid to use it directly on the image. What we will do then, often this Laplacian used with the Gaussian smoother, later we make it smoother, and use the formula of the Gaussian one. Then the Laplacian of the h, as we gave here, can be changed to the Laplacian of Gaussian or LOG. Then what we understand that due to the problem that this Laplacian formula can generate or create, specifically on the edge of the image that we are going to mix it with the Gaussian formula, and then as it's mixture between Laplacian as well as Gaussian, we know it as the LOG, okay, formula. Then the Laplacian of Gaussian or LOG is something like the Mexican hat, as you can see here, function, because it's appear. And if I want to show you the figure of that, it's something like that in the 3D plots. Even we have the same in the MATLAB. And this LOG cross section showing the zero crossing here from the side of our plot. Just see the figure of this LOG one, and then it's give the some sense about this LOG or Mexican hat as we have. Then if we want to implement this LOG, what we should do, the implement of this LOG is convolved with the edge, and the result is the Laplacian of or the following mask with the approximate the LOG is used, as you will see the matrix here. Then to detect the edge, the resulting image is threshold or setting all its positive value to the white and the negative value to the black, and the zero crossing between these white and blacks will be found. Something like the ratio black and white will be come to the picture. Black will take the 0. And sorry, some negative value will assign to the that we can find in this. Suppose we have one example, some I think medical image that we can have here. The original one is as we can show here. If I use the Sobel gradient, I can show it like this. See some something like vessels are clear more here. Then if I want the special Gaussian, we can have this plot. Then you say the Laplacian mask, LOG, and thresholding LOG and zero crossing. These are the three effects. And then you will see that thresholding LOG will may have more informative, or even it will remove some part. But if you suppose you want to see that vessel or that road that it created better, maybe it will be more effective for you to see. And just remember that any of these edge detection, we should select based on the application that we have, or other way. You should know where you want to reach. You want to reach the university, or you want to reach any other store. Okay, then you should take the target and method to analyze. Uh, then with this information that just now we review, we can think about the edge linking and boundary detection. This edge detection algorithm can be followed by linking procedure to assemble the edge pixel into the meaningful edge. Then some basic approach, we have some local processing and global processing, which we can do it with the Hough transformation, Hough transformation, and global processing via the graph theoric technique. Then these are the approach that we can have to find the edge linking or boundary detection job. Um, how and why we should have the Hough transform is to find the subsets of the point that lies on the straight lines in the given image. And one possible solution is to first find all lines determined by every pair of the points, and then find all subsets of the point that are close to the particular line. For a given image, suppose if we have the n points, this procedure will involve finding n multiply n minus 1 divided 2 lines, and then again performing 1n multiply to the previous formula, which comparisons of the every point to all line. Hence, we have the Hough transform. Transform. Then, based on this edge linking of a Hough transformation, infinitely many lines pass through the xi-yi, all satisfying the equation of yi is equal to aixi plus b as a linear form. For varying the values and a and b, but there are only the single line which will be satisfy the xii plus yb. And in the AB plane, which we call it the parameter space for every point in the xy plane, and in other words, a second point of the xj yj, because what we want to do, we want to have the link between two edge Then we have xi and yi, and on the other edge, we have the xj and yj. On the same line in the xy plane intersects the line of xy, yi in the AB plane at the A prime, B prime, where we can say that this A prime is the slope and B prime is the intercept of the line containing both xiyi and xjyj in the xy plane. All points of xi, yi contained on the same line must have the lines in the parameter space of I prime, B prime with the edge linking base. Yes, here we will see the xy plane and the place of the xi, which yi, which can be performed as the axi plus b. Then now, if I have the 2 point of xi, yi, and xj, yj, the AB plan or parameter space will be something like B is equal to minus xi yi, as I shown here. And the previous analyzation that we shown can be here. See, the subdivision of parameter space into the accumulator cells where we have A minimum and A maximum and B max and B max are the accepted range for the slopes and intercepts value that we can have in our H. See the image as the matrix, and we have the B minimum to B maximum, A minimum to A maximum, and then now you can see the dots and parameter in the image and do the previous calculation between them. Then in the Hough transformer, the parameter space is then divided into so-called accumulator cells as the A max and A min, and B max and B min are expected range of the slopes and intercepts value. The accumulator cell of Aij correspond to the square associated with the parameter space coordinates of Aibj, and all cells are initialized to the zero. For every xk, yk in the xy plane, A is chosen to be each subdivision value in the allowed range, and corresponding B is calculated using the B as the minus AXK plus nearest allowed range. If a choose of AP result in solution BQ, then we can have the APQ and APQ plus 1. At the end of the procedure, we have the value Q, which is corresponding to Q point in the X y plane lying on the line of the AI X plus BJ. Then the problem of using the equation of X plus B is that we have the value of A, which is infinite for the vertical line. And to avoid this problem, now we can have the formula of the x cosine theta plus y sine theta. As you will see, all this information are the vectorial concept, or having the view of the image in the form of vectors, which in this formula it's used to represent the line instead. Vertical lines, which has the theta is equal to 0, then this rho equal to positive at y-intercepts, or theta is minus 90 with the rho equal to the negative y minus intercepts. As you will see in the figure, I show some part of this aging of Hough transformation. Then to have this process, first we should compute the gradient of the image and threshold it to the obtained binary image. Then we should specify the subdivision into AB, or P is equal to 0 for the plane. Then we should examine the counts of the accumulator cells or high pixel concentration. And in the fourth step, we should examine the relation or principally of continuity between the pixels in the chosen cell. Hough method is applicable to any function of the form of T is VC and 0, where V can be the vector of coordination and C is the vector of coefficient. For example, the Hough transform using the circle is described as the equation of the circle, as you know, x minus c1 power by 2 plus y minus c2 power by 2 equal to c3 power by 2. These three parameters, C1, C2, C3, and we have the cube-like cells and accumulator of form of the AI, J, and K. Then increment of C1 and C2, solve of C3, that satisfies the equation and update the accumulator corresponding to the cell associated with the tripled C1, C2, and C3 of this method. What we will do on the next lecture, we will see this form of transform or transformation in the MATLAB. Then it's become a little bit clear for you. What we review now is just we give the concept of this mask as well as method to detect the image. More practical part we should do and review in the MATLAB section part. Okay. For the first part of today's talk, it's okay. What we have done now, we talked regarding some edge detection method, which we may continue for the later also more, and we'll see the effect on different methods on the image later on. But another concept in this image segmentation is about thresholding, which in that thresholding may be viewed as an operation that involves the test against a function t of the form of t xy, pxy, and fxy, which in this formula, fxy is the gray level of point x and y, pxy denotes some local properties of this point. That means that the act that you can have or the function that you will implement based on some local property as well as the gray level point of a formula of the image can be performed as the thresholding. The threshold image of GXY then can be defined as two value of 1 or 0. If fxy is greater than t, then the value is 1, and if it's less than t, the value is 0. Thus, the pixel label 1 or any other convenience gray level, which it can correspond to the object, whereas pixel labels 0 or any other gray level that not assigned to the object correspond to the background. Okay, let us go more ahead about this concept. Yes. Then in thresholding, we have some concept that we should review. We have four types of global, local, adaptive, and multi-level thresholding. What are them that we will see in this slide? That in global thresholding, the T in the mentioned function depends only on histogram of the image, which in local thresholding, the T at any point, X and Y, depend on property of neighborhoods around the point. And in adaptive thresholding, the T it depends on both the neighborhoods property and spatial coordination. And finally, in the multi-level thresholding, classifies a point x and y belongs to one object class if t is less than fx and y and less than t2, to other object class if f x and y is greater than 2, and to the background if f x and y is less than t1. Um, some basic regarding the global thresholding. Uh, we can have that this global thresholding can be obtained either by visual inspection of the histogram or the image, or automatically from the histogram by the simple algorithm. You can find it in histogram we learned before, and simple algorithm that you can implement based on this global thresholding I written here. I mean, the algorithm which will be automatically and obtain the global threshold from the historical. First, you should select an initial or estimate for the t, and then segments the image using t, which will be produce two groups of pixel, G1 and G2. G1 consists of all picture with gray level values, which is greater than t, and G2 consists of the pixel with gray level values less than t. Then in the third step, we will compute the average gray level of mu1 and mu2 for the pixels region G1 and G2, compute the new threshold value. Then we will update the t with the this formula of t is equal 0.5 multiplied by mu1 plus mu2, and repeat the step 2 through 4 until the difference in t is successive and relative is smaller than the predefined parameter of t0. Then you will see that this cycle will be a start and this algorithm can be followed. See, suppose I bring one sample here, which in that the original image and image histogram are shown, and the result based on global thresholding, T midway between the max and minimum gray level are indicated here. What the change that you can see from these tools, we have the whole which will be clear here, and even the image is much more smooth, you will see. Um, and something that we should mention here is that using the T midway between min and max gray level produce the binary image as it shows in the figure. Later, there is one more example as the automatic approach which they use with the fingerprint. You will see the original image and histogram of this image and result of segmentation with threshold estimated by rotation. You will see that the clear value of the histogram and effectiveness of the segmentation between the object background. Here we had the T0 equal to 0. We followed 3 iteration and the resultant T was 125. Then you will see that the results picture is much more clear. Even the line is much more better. In the feather, you can analyze it better, and maybe you can distinguish between 2 or 3 people based on this. Then another thresholding method was adaptive thresholding, which in an image where we have the fixed global threshold, this algorithm does not give the acceptable result. For example, an image with poor illumination. A basic adaptive thresholding technique can be explained with the below algorithm that I bring. Then first, the image is divided into some smaller sub-image. Then individual thresholds are chosen to segment each sub-image, and the threshold thus select or adaptive to pixel value in individual sub-image. The improper subdivision can result in poor segmentation and further subdivision of improperly segmented sub-image and subsequent adaptive thresholding can improve the process of segmentation. Now you will see the result of this adaptive thresholding here, original image, result of global thresholding, then you will see that image is subdivided into the individual sub-image and result of adaptive thresholding that is clear on the image. Again, another example with the adaptive thresholding and histogram shown here, which probably of the improperly segmented sub image from the previous example. Figure B and C will show the corresponding histogram of them, of each image, and further subdivision of improperly segmented subimage, and finally histogram of some small part of the image as the result of segmenting, you will see. Now, two methods of thresholding we describe. The optimal global and adaptive threshold is the third method of thresholding that we are searching for that. Think, consider as an image with two principles of the gray level of P1Z and P2Z as the peak I show in the figure, as the gray level probability density function of two regions in an image. We can assume the larger of two PDFs corresponding to the background level, while the smaller describe the gray level of object in the image. Then which one is optimal and how we can have the optimal global for our threshold value selection. Okay, then as we said, the optimal global and adaptive threshold is the mixture probability density function which describing the overall gray level variation in the image. We can have the formula as mentioned here, which in that P1 is the probability or the number that pixel is an object pixel. Similarly, P2 is the probability that pixel is a background pixel. And the image is segmented by classifying all pixels with gray level greater than threshold T as background. All other pixels are called object pixel, and the probability of erroneously classifying a background point as an object point with the formula of E1T, integration between minus infinite to T with the P2Z and differentiate with the Z. Then similarly, the probability of this erroneously classifying an object point can have the background with the formula, and then the overall probability errors is something like estimated E with the P2 E1 T and P1 E2 T. To find the threshold value for which this error in minimum require the differentiating ET with respect to T using the Leibniz rules and equating the result to zero. These are the mathematical analyzation for this type of optimal global. And this above equation is solved for T to obtain the optimum threshold value. Something that we should note here is that P1 is equal to P2, then optimum threshold is where the curves for P1Z and P2Z are intersect. Obtaining an analytical expression for T requires that equation of P2 PDFs are knowns. Then if I want to give the example of this, some use of PDF, we can use the Gaussian density of P1Z and P2Z as the below formula, which in that the mu and rho are the mean variance of Gaussian intensity on object, and mu2 and rho22 or 22 are the mean variance of the Gaussian density of other object in the mentioned formula. Then we can have this formula, which in that the t as the threshold can be calculated with the average of the means. I think these formulas will help you to understand the act of the function on the real photo when we'll see later. Then just remember or have some idea about the calculation method of them. Another one or the methods that we followed for the thresholding was local thresholding. Two methods we review. Uh, then the next one is local thresholding, which in that the chance of selecting a good threshold are enhanced consequently if the histogram peaks are tall, narrow, symmetric, and spread by the deep valley. Okay. Then finding maximum or the proper value for the threshold is not simple. Suppose you will see the card diagram showing the imposed boundary here as the local threshold example. And one approach for improving this in local thresholding is to consider only those pixels that lies on the near the edge. Then in this, the histogram or less depends on the relative size of the object and the background. And this, however, requires that the edge between the object and the background are known. The identification of whether the pixels are on the edge is done by using the gradient, and the identification of whether pixels are on the left or right edge is doing by the Laplacian. Then you will see that we have the combination between gradient as well as Laplacian to find the local thresholding. These two quantities may be used to form a three level of image as follows: 0, minus, and plus. And all pixels that are not on the edge, we can label them as 0. You will see it takes the gradient of them is less than threshold, then we will put 0. All pixels that are on the left side, that we know it as the dark or left, we know we will label it with plus, and all pixels that are on the right or light side, we know it as the negative label value for the thresholding. Then the transition that we can have from 0 to plus indicate the transition from a light background to a dark object, and 0 or plus indicate the interior of the object. Transition from plus to minus indicates the transition from a dark object to the light background, and thus horizontal or vertical scan line containing a section of object has the following structure. You have some minus plus, 0 or plus, and then plus and minus, something like that, where this dot party, this is the combination of minus, plus, plus, minus, and 0 value. Now, suppose you can see some local thresholding method as an example of handwriting, which is store coded by using the threshold technique. That was some handwriting which define and find, suppose, some word. And another example can be the original image and image segmented by local thresholding. Now you will see that the background is removed, something like bank check, as you will see. And then now the handwriting become clear, means that it's remove the background, and now you can have the more informative image based on your target, and you can see that how effective this low-card thresholding is working. Okay, it's okay for today part, means that we review the thresholding as well as some method of edge detection. We have more talk regarding segmentation. This chapter is not much more big, but it's okay. It's very nice chapter, I think, because the real application will come to this chapter and concept that we can review for that. Uh, I think that you review the points that I said, and for the next lecture, I prepare some MATLAB work after the theoretical work of this chapter. We may have some of these filters and mask uh, effect on the image, and we talk regarding that. If you don't have any question, we can be ready for Roy section. Um, I think uh, as this is also the first experience, I wish that it will be